Good morning, friends. Today we have discussed fluid power control. Unit number 3. So, learning objectives of this lecture to understand the different pressure control valve and their application in fluid circuit. Learning outcomes. At the end of the session, student can understand different types of pressure control valves and their application in fluid circuit. So, see counterbalance valve. So this is pressure control valve. Counterbalance valve. Now, see in this figure, when the DCV is shifted to left position, this position, cylinder will not extend until the present pressure is reached. See, this is tank, this is PRV set on 350 bar. Oil goes to through PRV from the tank to this solenoid control valve to like that here. So here pressure 350 bar pressure is applied, then cylinder will not extend until the present pressure is reached in the rod end, which is set at counterbalance valve. So this valve here we have set means for example we have setting for 350 bars pressure, and this counterbalance to balance this pressure by this counterweight. So here pressure also apply by this weight on here. So which is set counterbalance valve, which is a closed one, like that. Closed one means the weight of this body acting on this fluid. So equivalent force, when this pressure force is maximum, then this weight going to extend like that. This is called counterbalance valve. See, pressure is building at the rod end, then the going to tank this liquid to the return this tank. This is counterbalance valve. This provide the back pressure against the rod end of the position, which acts stabilize the downward movement of the cylinder. After building the sufficient pressure at the rod end, the valve gets open, and then the rod is lowered very slowly as seen in the next figure. Counterbalance valve open position adds. After building the sufficient pressure at the rod end, the valve gets open. See, these provide the back pressure against the rod end of the position, which act to stabilize the downward movement of the cylinder. After building the sufficient pressure here at the rod end, the valve gets open. The valve gets open. And then the rod is lowered very slowly. Rod is lowered very slowly. As seen in next figure, counterbalance valve open position as, see, this is counterbalance valve in open position like that. See here, counterbalance valve in closed position because here here check valve also present, non-return valve. This is counterbalance valve in open position. Here counterbalance valve in closed position. That's why create sufficient pressure in this here. After creating sufficient pressure, this valve is open, means this liquid going to this here, going from here to the tank. So open this valve. In next figure, we can see here this counterbalance valve is open and liquid go to the tank. Counterbalance valve, when we want to rise the rod, shift the DCV position to cross configuration, then the check valve allows all the fluid bypass and cylinder retracts very quickly. Counterbalance valve. When we want to rise the rod, shifted the DCV position to cross configuration, then the check valve allow all the fluid bypass and cylinder retract very quickly. See here, like that. Counterbalance valve. When we want to rise the rod, increase this rod, shift the DCV position to cross configuration, means here. The check valve allow all the fluid bypass and cylinder retract very quickly. When we have changed position from here to here, then liquid goes to like that, and here force is applied, then liquid goes to increase the weight. Increase the weight here also. So to check valve, allow all the fluid is bypassed and cylinder retracts very quickly. Cylinder retracts very quickly. A counterbalance valve has internal drain. Unlike the sequence valve, which has an external drain. This is counterbalance circuit. We can see here. In this, we have in previous figure, we have seen this position, but here we have seen this position. In this position goes. Counterbalance valve, remote sensing cap and P. Counterbalance valve can also be operated remotely, as in the circuit, the pressure is being sensed in the cap end line. The counterbalance valve can also be opened remotely, as in this circuit, the pressure is being sensed in the cap end line. The setting of the counterbalance valve will depend on the magnitude of the weight being lowered. The setting of the counterbalance valve will depend on the magnitude of the weight. Counterbalance valve, remote sensing. Counterbalance valve can also be opened remotely, as in this circuit, the pressure is being sensed in the cap end line. Cap end line. See, remote sensing. In this circuit, the pressure is being sensed in the cap end line. The setting of counterbalance valve will depend on the magnitude of the weight being lowered. The setting of counterbalance valve depends on the magnitude of the weight, means weight of this weight or body being lowered. Just as with sequence valve, this setting should be as low as possible, because the pressure drop across the counterbalance valve is wasted energy that is converted to heat. Just a sequence valve, this setting should be as low as possible, because the pressure drop across the counterbalance wall is wasted energy that is converted into heat, means because this is closed in position. So then the setting for any particular circuit is determined by trial and error and must be adjusted if the weight is changed and must be adjusted if weight is changed. Brake walls. Like a counterbalance wall, brake wall can be used to prevent road from accelerating uncontrollably. Like a counterbalance wall, brake wall can be used to prevent road from accelerating uncontrollably. So counterbalance wall used with cylinder brake wall are used with hydraulic pneumatics motor. Brake wall are most commonly used in circuit in which the motor must lower a large weight. Example, winch applications. Like counterbalance wall, brake wall can be used to prevent road from accelerating uncontrollably. So counterbalance wall used with cylinder brake wall are used with hydraulic pneumatic motors. Brake wall are most commonly used in circuit in which the motor must lower a large weight. Example, winch applications. See here, we can see brake wall prevent road from accelerating uncontrollably. So counterbalance wall used with cylinder. See, this is here counterbalance wall used with cylinder. Brake wall are used with hydraulic pneumatic motors. This is a bidirectional hydraulic pneumatic motor. This is brake wall. This was mostly used in the large for the lower the must lower a large weight. Winch applications. Brake walls. We can see this is brake walls. See here inlet normally closed. So this is low piston area, smaller piston area, external pilot pressure, 8:1 ratio, internal pilot pressure, inlet, brake wall. Here we have applied the pressure. Hydraulic motor in run mode. See, this is the circuit for hydraulic motor. This is brake wall. See, hydraulic motor in run mode. 8 psi. Here 100 psi. This is motor. This is the brake wall. This is circuit. Here, this is acting position. After that, this is brake wall. Here, return pressure sensors. Hydraulic motor, this is in run mode. See, in run mode, this liquid going to like that. This is in run mode. Here, check valves. Here, in closed mode, see this pressure going to downward. In closed, this is closed. Then the brake the motor mode. Motor is brake mode. So hydraulic motor in reversing mode. In reversing the motor, no braking, free flow. If the require braking, press one or more check valve at the top. In the reversing motor, no braking, free flow. See, this is our basic circuit. This is our three position valve. See here, this is liquid going to like that in reverse position. For in second or cross position, liquid going to like that. Then in this like that. So, and return to the position. So see here, this is our brake valve. If reversing the motor, no braking, free flow. If you require braking, press one more check valve at the top. We are required to brake means one more check valve at the top. So braking with cross port grip valve for both DCV direction control valve position. Braking with cross port grip valve run mode. See, this is A, this is port B. A here, liquid going to in this direction. In this here, run mode, return to B positions. Close this. Like that. Braking mode. In braking mode, see stop in middle position. This is stop. Liquid going to like that. Back pressure. Yeah. Brake. Yeah. See, we can see here on. Which liquid going to like that. This is open and pressure going to back pressure. Like that. Run mode counterclockwise. See, in third position of the DCV, liquid going to in return position counterclockwise. Then this valve is closed and operated by the spring like that. Brake mode counterclockwise. In the here, brake mode counterclockwise, we can see in this circuit back pressure. Specification of pressure control valve. So here we are specified using maximum pressure, maximum flow, filtration level, fluid type and viscosity range, physical size, mounting and porting. Here we specified using maximum pressure, maximum flow, filtration level, fluid type and viscosity range, physical size, and mounting and porting. So any doubt, any queries, please ask me. So today, thank you. Today we are stop here. So any doubt, any queries, please ask me. We are today we are discussing counterbalance valve, brake valves, hydraulic motor in brake, hydraulic motor in run, run mode of counterclockwise, run mode of motor, like that. So today we have stopped. Thank you. Stop here. Thank you.